Cool. Assuming everybody is there and everybody can see my screen and can hear me. All right. Welcome guys. Welcome back. This is the fourth session in our journey across DevOps. We've probably discussed a couple of things in our journey so far. We had a very, very long and a lengthy discussion about what DevOps is. We all try to understand what is it that a DevOps resource or a candidate does. We also then had some sort of lab where we tried doing some local application development. We wanted our own environment. So we used Vagrant to provision ourselves a virtual machine in an automated way. And then we used or tried to deploy WordPress as an application on top of that instance. Everything was done manually. Of course, the Vagrant part was automated, but other than that, yeah, installation of the application itself was manual. And then, yeah, that concluded that particular lab or the first part of it. The second part where we took that same process one step ahead, we tried automating what we did in part one, which was basically to automate the whole setup of WordPress app using Ansible. So we used the same setup that we had. We still used Vagrant to provision ourselves a virtual machine. And then we ran an Ansible playbook that basically deployed the app onto the virtual machine, and we could do our local development and things like that. So for this session, we are probably going to step one level further. We're going to now have some basic understanding of Docker and how Docker works and what is Docker, and probably try to help you guys understand how Docker can help in application development and deployment and things of that sort, right? Again, what I'm going to cover in this session is very, very basic of Docker. There are tons of videos and resources on YouTube or on the internet, which will give you very advanced view of Docker, but this is just to get you to understand what Docker is. So if you think, or if you have already experience with Docker, probably you can jump in and try to convey some points across. If not, let's start, guys. So what is Docker? So Docker is an open platform for developing and shipping and running your applications. So it also enables you to separate your application from your infrastructure so that you can deliver software quickly. What does this mean? So you typically, when you do any sort of application development, probably around 5 years ago or even 7 years ago, you always would have to spin up your own server or a virtual machine or whatever it is. You would then configure the virtual machine, and then you will deploy your application on top of it. But what Docker provides is the ability to package and run an application in a loosely isolated environment called a container, right? So Docker has this concept of a container, which basically means it's an isolated environment within your machine or within a virtual machine or within a cloud machine or an EC2 instance, whatever it is. But it's very, very loosely coupled with the underlying infrastructure. That gives you a lot of advantages. We'll discuss that in the subsequent slides. But the isolation also gives you the security, and it also allows you to run multiple containers simultaneously on a host. So that gives you basically advantages in terms of cost, in terms of better utilization of your hardware. So you could have multiple containers running on a single virtual machine or your server or whatever it is. And you can use your hardware in a bit more robust situations. Now, what are containers? Containers themselves are a lightweight, let's say, package, and they contain everything you need to run an application. So you don't necessarily, so in a container, you don't necessarily ship an entire operating system, although you can. But so you do get containers of your Linux operating system itself, but that's not the whole idea. The idea is you just package your application with what you need to run your application, and everything else Docker takes care by integrating itself with the underlying host. And then you can easily share this container with Docker, and your work as well can be easily shared with anybody. So for example, again, this is something that I'll show you later in the class or in the session, but we can build a Docker image on my machine, and then I can upload it to a central hub, which is also called a Docker registry. And then you guys can pull down the same image and you will get the exact same result as what I got here. When I say exact, it is absolutely exact same result, unless the container has gone bad or something, but that's very, very rare, but you'll get the exact same result. Right, so let's proceed. What can I use Docker for? Again, it's for fast, consistent delivery of your applications. So Docker streamlines the development lifecycle of an application by allowing developers to work in a standardized environment using local containers, and you can then develop on your local containers. Again, once your development on your local containers are done, you can then ship it to your local registry or a central registry on the internet, and then you could run your applications on the internet, or you could share your containers with, or your work with somebody else, and then they can continue the work. They can update it and then ship it back to you, whatever, right? And these containers are very lightweight, right? So for example, if you install an operating system on your computer, let's say a basic Ubuntu release or a Linux or a Windows operating system, it would typically run in somewhere in gigabytes in size, right? So your typical installation of Ubuntu, let's say, is around 6 or 7 gigabytes, Windows around 10 or 12 gigabytes in size. And then the additional software that you have to install on top of it, and then whatever you need as your part of your application. So that's a very huge chunk of your virtual machine. But with Docker, because it's very, very lightweight, all you're shipping is just your application and nothing else. So if I write an application that says prints hello world, again, this will be shown in the example. But if I write an application called hello world and it's just an HTML page, I can just ship that single HTML page in a Docker container to you guys. You guys can run it. You guys can view it. If required, you guys can update it, and then again push it back onto a central or a hub or a registry, and then I can continue to work on it and pull it down and back again. So that way, it gives us a very, very small work environment, but a full-fledged application that works anywhere. The containers are also great for CI/CD workflows, which means you could have a temporary environment that would run your application. You can run your tests on these containers, and then you could tear down the whole environment. That way, you can get to test how your application change works. Let's proceed. What can I use Docker for? Again, a little bit more expanding on the same topic: responsive deployment and scaling. So Docker container-based platform allows for highly portable workloads. Docker containers can run on a developer's local laptop or a physical or a virtual machine or in a data center or in the cloud, and in a mixture of these environments as well. So what does that mean? So when you do an application development, if you would want to test your changes, assuming Docker was not there, you would then have to copy your changes or deploy your changes onto your virtual machine, restart your infrastructure or your web server or whatever it is, and then make sure it all comes up fine, or you hope it comes up fine, right? But with Docker, it is very, very easy to make your changes. You just update your file, you build your new image, and Docker can immediately run it, and off you go testing your applications. You could run multiple applications side by side, and then Docker would show those applications working as well. So that way, Docker is very, very responsive and scalable. You can also use it to run more workloads on the same hardware. We sort of covered this on the first slide, sorry, the second slide, where we were talking about what Docker is. But again, because Docker is very lightweight and just uses uses a very, very loosely coupled abstraction with the underlying operating system, it provides you the ability to run multiple containers on a same hardware or on the physical hardware. So for example, on my laptop, I could run 10 to 15 Docker containers easily without causing any slowness or something on the hardware itself. But if I have to run 10 or 15 virtual machines, I'm sure I can't afford, or my laptop doesn't have such capabilities, right? Let's quickly touch on Docker architecture. Again, this is something that I've taken from the Docker website itself. You can read a lot more on the Docker website, which is linked on the bottom right-hand side of the screen. You have very, very excellent documentation on Docker itself and how the architecture is and things like that. But just briefly touching on it, Docker uses a client-server architecture. The Docker client talks to a Docker daemon, which does the heavy lifting of building, running, and distributing your Docker containers. So as you can imagine from that first sentence, Docker itself has two parts to it. When you install Docker, you do get the Docker daemon or the server itself, and then you have the Docker client itself, which you interact with the client with your commands, and the client then talks to the Docker domain and Docker daemon, and then it will the Docker daemon does most of the work. So the Docker client and the Docker daemon can run on the same system. You can connect to a Docker client to a remote Docker system as well. The Docker client and the daemon communicate using REST API over Unix sockets or a network interface. So a client can talk to the Docker daemon or the Docker host. Again, anywhere in your network, you could have a remote Docker daemon, and then you could connect your laptop to that Docker daemon, or you could run everything locally, or you could have it on a cloud and you could connect to it and things of that sort. Typically, when you do a Docker install, it's discussed in the next slide, you would probably install everything on your local machine. Again, these are very, very lightweight installations. And yeah, you would have the complete package, and that will let you develop everything locally. We'll explore that in the coming slides. You'll also have another Docker client, which is also called Docker Compose. It lets you work with applications consisting of a set of containers. So for example, if again, taking the example of WordPress, if you have multiple, like you have this 3-tier architecture, you have a database, you have an application or the middleware layer, and then you have the web server. You could have containers for all 3 of these components, and then you could use Docker Compose to combine all these 3 components. And then when you say bring up this infrastructure, it will start up all 3 of them, helping you do your development quicker. So Compose is an excellent tool to do that. Right. We'll talk about some of the Docker terminologies that we will talk when we do our hands-on practical labs. We have something called as a Docker daemon, which we have spoken about. We have Docker client, which we have spoken about as well. We have something called as Docker registry or registries. These are nothing but specific, I would say, applications where you could share your Docker containers. Right? These hold your Docker containers. We will touch on Docker registries, and I'll show you one of the registries that we have. And yeah, that will probably give you some idea of what a registry is. And then you have something called as Docker images. Images are nothing but your local application or your applications that are developed using Docker, and the ones that are saved locally. And then you have Docker containers, which is the actual application itself, or the container itself, which runs your code for any n number of time or duration, and then you could have it either shut down after the work is done or deleted after the work is done, and things like that. Right. So one note here is Docker is written in the Go programming language and takes advantages of several features of the Linux kernel to deliver its functionality. Docker uses a technology called namespaces. So these are Linux kernel level namespaces, and they provide, and it helps it to provide isolated workspaces called a container. When you run a container, Docker creates a set of namespaces for that container, and each namespace provides a layer of abstraction, right? And again, these could be a little bit or these topics could be a little bit, what to say, advanced. And that's why I'm not going to explain a lot more about Linux kernel or its namespaces, but that's one of the fundamental features of Docker is it's written in Go programming language, which is very flexible and very fast. And then it uses the Linux kernel level functions, which are already there in the kernel, to provide you that layer of abstraction between the actual operating system and the container itself, using something called as namespaces. Cool. Hopefully that should be enough detail about what Docker is and how Docker works. How do you install Docker? Again, as part of this particular session, I'll not walk you through the installation process. The installation process itself is very, very simple. It's just downloading a exe file, or if you're on a Mac, image file, or DMG, and then double clicking on it, and then going through the process, which is just clicking next and accepting terms and things like that. It's pretty straightforward. It doesn't need any special settings and things like that to be enabled. Again, it's a very, very lightweight container, and you can easily install Docker. The link is there on the screen here. Once this presentation pack is shared, you could probably try visiting this link and installing Docker on your machine. Cool. Now, how do we use Docker? Again, these commands, when I say it on the screen, might sound very weird, but yeah, we will have a practice lab to see how this all works. So if you have to run a single command, you invoke it with the Docker command. So that's your client. You're saying, you're telling the operating system to invoke the Docker command, and then these are the sub commands that you invoke. So you say run, and then you pass some flags to the run command itself, and then you pass it an image name. When you say an image name, it could be the application you have deployed or you want to develop or something of that sort. You could have your own images, and then you could pass extra arguments to these images. So I've given you an example below. It says docker run -i-t nginx :latest and then /bin/sh. So what it means is I'm asking Docker to run nginx container and the latest version of nginx container. So for example, today it could be nginx 1.0. Again, I'm not saying this is the latest version, but as an example, it could be nginx 1.0, and in the next 5 minutes, it could be nginx 2.0. So latest is just a tag. A tag can be added to n number of containers. Again, I'll walk you through this process shortly. And what you're asking it to do is run it in an interactive mode, which is with the -i flag. And then we run a command, which is /bin/sh, which will basically give us a shell within the container itself. Again, not the best example, I agree. But just to give you an idea of how to run a Docker command or a container. Let me quickly pause there for a second, just check if you guys have any questions, if you've popped in any questions in this thing here. Cool, I don't see anything there. All right, so let's quickly continue. Now, we're just going to talk about another concept in Docker, which is also called as a Docker file. So Docker file is what we as developers or DevOps resource maintain and manage. One of the things that we do in the application development lifecycle is to write a Docker file. Docker file is nothing but instructions to the Docker client on what needs to be done as part of your build, or as part of building the container. Now, if you see the example below here, some of these might look very simple, and again, yes, it is. It's not very hard to get introduced into Docker and start using Docker. So what we're telling in the first line of this example is you're telling Docker to start from a base image. Now in our case, we have said use the base image from Ubuntu, and it's Ubuntu with the version 18.04. Again, you could have multiple versions of your image, and this is an image that's provisioned by Ubuntu themselves, right? So start from there. The next is we've added a command in there that says maintainer, and I've just given my name. All it does is if somebody tries to use the same image and they have issues with it, they have a point of contact, right? It is just an information to tell the end user who's the owner of this particular image. So on the Docker registry itself, you can see multiple images with multiple owners. And say, for example, if you try to use one of the image and it doesn't work as intended, or if there's a problem, you could go back to the maintainer and contact them and ask for some help, probably, right? The next command is called the run command. Again, what this instructs Docker is to run the below commands and do something within the container itself. In our case, what we're asking Docker to do is, once you download this base image of Ubuntu of version 18.04, please update the image to the latest patch level or whatever you have. And then in the subsequent command, you also install Apache 2, which is a web server. And then once you have installed Apache 2, you delete the default index.html file that comes with the web server. And then you also remove your package cache, right? Now, the reason why you do this last line here, which is to remove the package cache, is to reduce the container size. Say, for example, if your container size after running all these commands is around, let's say, 100 megabytes in size, if you remove your package cache, it'll probably come down to 70 megabytes. And that's making your container very lightweight and small, and that will help you easily ship it across to people. You're removing the default index.html file. It's probably one of the best practices in the industry, where you delete the default index.html file and add what you want to add into the web server. Again, we'll go through this in the lab. I'll show you an actual Docker file and how it works, and we'll try creating an image, and probably that will give you an idea. All right, so let's quickly head on. Cool. So we are in the labs section. What are we going to do in this lab? Or of course, this is just one example. I'll show you a couple of examples in the lab. But what we're going to do is we'll create a Docker file. We'll run Docker images and explore a Docker file and see how a container is, what the container does. We'll make changes to the files, which is the Docker file in this case, create new images. We'll push it to Docker Hub. And we'll also talk about Docker Compose, list its advantages, which we have done sort of, but we'll talk about a little bit more about Docker Compose and see how it can help us. All right. Now, let me quickly share my terminal session or my terminal window so that we could talk about Dockerfile and things like that. Hopefully this is, the font size is big enough for you guys and you can see what's happening on the screen. So let me first show you one Dockerfile that we have here. I've seen something here that says, okay, you want more zoom in. So, okay. Is this good enough? Hopefully it is. I'll just cat this Dockerfile, more zoom, okay. 1 minute, guys. Okay, so this is the max I can zoom. I can't zoom anymore. So hopefully you should be able to see now. Cool. I'll just quickly show you how a Docker file looks like. So I've already written a Docker file. In this Docker file, I've said from nginx:/latest. So you start from the latest image of nginx. I've set an environment variable, which is called author, and it's my name in here for now. We've said the current working directory is the nginx HTML working directory, which is where basically nginx serves all its web pages from. We have a local copy of a file called hello.docker.html. We are telling or instructing Docker to copy this particular file into this location. And then we are doing something with this file here, which is basically replacing the author variable, which is the environment variable we set here, to the one that is here, and basically starting the nginx container, right? So how do you build this Docker file, or how do you instruct Docker to build a container with this particular data, right? So what you could tell is, you could say Docker, and then you could of course hit Docker and enter. You would get a good command history or a help as to what you need to set or what options are available. In our case, let's just start building it. So we'll just say Docker build, and then with the build command, you need to pass it a tag to your Docker image, right? So we'll just call it Docker build -t labs, or we'll just say nginx colon 1.0. So 1.0 is a tag that you pass to Docker. You could have n number of tags. You could call it 10.1 or whatever is your application version is. It's up to you. So for this example, I'll just call it 1.0, and then we pass it a Docker file to use, and then we'll say dot. Now, in a typical development environment, you would have multiple Docker files. Again, that's the case in this particular terminal as well. And that's the reason I need to pass it a Docker file to use. Others by default, it'll just look for a file called Docker file, which is what we saw earlier. And you're just asking it to build it in the current context, right? So the moment we do this, what it'll do is it'll start pulling the latest version of nginx from Docker Hub, which is what you could see here. And then as soon as that's built, it said I'll use this work directory as nginx HTML. I'll copy all the files. Once that's done, our instruction set was complete, and then it saved or named it to this particular name, right? So now if we see Docker images, for example, there are a number of images here, but you could see this is the one that we just built. So nginx colon 1.0, right? Now, one good thing is, okay, let's first run this image and then see how this works. And then I'll also show you the process to export this into the registry or hub, where you could also pull it down if you're following along, right? So how do you run this particular image that you just built? Now, again, it's simple. So you say Docker run, you pass those flags that I said before, -i, -t, and you could pass it all together, or you could pass it separately. It's up to you. And then you give it the image name, which is this. Before that, we need to, because this is a web server, we need to tell it what port we need to expose it on. So we just pass the port here, -p 80:80. And then you say nginx 1.0. So what this does is it starts up the nginx 1.0 container, which is the one that we created. It exposes it on port 80, which is on the local machine, or basically the remote port and the local port. So on the local machine, it'll be available on port 80. You could have it on any port, and then it'll just launch it in an interactive mode. So I'll start it just like this as a test. And let me quickly share my screen and show you how this looks on a browser, right? So if I go to the browser here, and then if I say localhost colon 80, and there you go. So it said hello, and then Sunil. So this is what we were replacing in the Docker file with the author name, and it says this is being served from Docker using an nginx container. Excellent. Now let's go back to that terminal window again. And let's do something special. So you can see it being run here. Let me press Control-C, and the container should stop. And there you go. So it stopped. We can see how we can see the Docker containers or processes using the Docker PS command. So you can say Docker PS -a to list out all the containers, and you can say we ran nginx 1.0. This is the container ID of it. We ran a command. Don't worry about it for now. It was created 55 seconds ago. It exited with 130 because I pressed Control-C, and it has given it a generic name. You can specify what name you want as part of your command, but for now, I'll not go into those advanced topics. Now, let's do something very simple. So let's go into or edit the same Docker file again. And here in this case now, let's change this author from Sunil to Raj, assuming this is your application development flow, right? So you had to make a change to your application. You have made the change. You have saved the Docker file. Let's run the same build command again, but now let's tag it with 2.0 because it's your new application. You're tagging it with a new tag. You're building the same build file again, and there you go, right? So what Docker will now do is you see how the build was. It was so quick because it did these changes only where it was needed. So it changed just that HTML file, and then it reused everything from the previous build, and your build was complete. So let's quickly run that image now, just to give you a demonstration of how it looks. The image runs. I will share my screen again, in this case, the Firefox window. Now I'm on this localhost screen. I'll just hit refresh, and you can see the thing changed to Raj. Your application, you could instantly test it with, in this case, being a web browser. And you could instantly test it with a container. If you didn't like it, revert it back, run the old container, and you could start making more changes. Hopefully that shows you how quickly or how quick you could do your application deployments. Now that we have two containers, let me quickly show you how Docker registry looks, right? Let me quickly share another screen. Give me a minute. All right, where is this share? All right, share. So I hope you all can see the screen. I am on a website called hub.docker.com. So this is on Docker Hub. We have a registry called New Mentor HQ, and I've been testing or pushing some images in here. In this case, it is Apache 1.0, just to test how it works. Right now, as you can see here in this repository, we just have one repo, and we have one tag or an image here. Let's try pushing these two images that we just created into this repository or the registry so that you guys can pull it. So this is the concept where we spoke about sharing images. So I have now two containers or images on my machine. I want to share it with you guys, right? So for you guys to develop or you guys to test. So we can do this using a common hub or a registry here. So let me quickly jump back into the terminal session of the window. And what we have to do to share these images is to basically tag them in the name we want it to be tagged. So we have these images now. So we have Nginx 2.0, we have Nginx 1.0. They are 133 megabytes in size each. And then let me share this across with you. So how do we do this? So we use an option called tag, right? Now, what we are doing is, you remember when we built an image, we passed a -t parameter. That was the tag of the image. So in this case, we had Nginx 1.0. So let me put that in here, Nginx, and then we will pass it on to, or upload it onto the registry as well with that same name. So on the registry itself, so this is our registry name or the repository name, and then we are tagging the image as Nginx -1.0. So let me tag the image. Let me tag the other image as well, which is Nginx 2.0. And then let me just say Docker push, and let's push this image to the registry, right? And there you go, it's preparing the push. This depends on the upload bandwidth that you have. In our case, it should be pretty fast, but I will still, we'll still wait until this is done. So it's trying to push. And what we should see, let me quickly go back to the other screen here. So let me share my Safari screen again. And if I go back to this registry again, and refresh the screen, you should now see another image, which is Nginx 1-0, which is what we just pushed a few seconds ago, right? So let's push the other image as well. I do have a question here, or if you have questions, please post it. If it's too fast, do let me know. I'm just trying to cover as much as possible during the session. Let's quickly push Nginx 2.0 as well. This push should also be pretty fast. So as you can see here, you do see messages here that says layer already exists, which basically is telling you that Docker is reusing its layers, and it's pushing only the change that is required. That way your container sizes always stay very small. Right, so we have pushed the other image as well onto the registry. So for you guys, after this session, if you want to pull down these images, you could browse to this new mentor HQ slash DevOps slash DevOps labs slash, and then you could give it an image name and you could pull down these images and you could use the same commands that I ran, and you should get the same result. So you should see on a web page, hello Sunil or hello Raj, and then the other text that is there. And that way you get the exact development environment that I had. So you could see some advantages of this process or this approach, right? Because it does tell you how quickly you could or how make changes to your application. It's a rapid application development lifecycle. And then once the application is deployed or developed, it's a very easy process to update your images or change your images and change your application as well. So hopefully you guys can see the value add in it. Let me quickly go back to the PowerPoint presentation. I'll come back and talk about Docker Compose in a little while, just before we conclude or go into the Q&A section. Let me quickly proceed on to the next slide. These are some of the tips that I have. Again, you can find this on some of other websites on the internet, but something that I have noted over the years of using Docker. So some of these are I would say best practices that I would advise you guys when you use or write Docker files. So one is to check the order of your commands. So ideally, as soon as you use a base image, you would want it updated. So you probably run the update command first, right before you do anything else. You use specific copy commands to limit cache bursting. So what does that mean is you don't want to copy everything in your current working directory onto the Docker container. Maybe your application doesn't need all the files. Maybe it just needs a HTML file. In our case, it was just the hello world example HTML file. We didn't want to copy everything over. So yeah, use specific copy commands. The next option is don't use too many line buddies. What does line buddies mean? So if you remember seeing the previous Docker file, the example there, you would probably realize, or you'd see those slash commands at the end of every line. So those are called line buddies. So make sure you limit it, not too much. Too much is too bad, but yeah, that'll help you build a better Docker file. You also start with an official image when possible. Say, for example, if you're building an Nginx or a web server, you want to use Nginx, you probably want to go with an official Nginx image. N number of users on Docker registry have Nginx. So for example, I could customize Nginx and have an image there. Raj could have one, you could have one, but when possible, use the official image and try to avoid images done by a specific user unless you have the real need for it. I'm not saying no, but unless you have a need for it, yeah, try to use official images. If an official image is not available, or if you can't, or if you don't want to use one, you could always build your image from scratch. If you remember, in the very first session, we spoke about a tool called Packer. You could use Packer to build your own images in Docker, and you could use those images. Again, use specific tags. So always tag your images with something meaningful so that you understand what that is. So for example, application versions, application names, and things like that. Always remove the package manager cache because that increases your container size. You always want to fetch your dependencies in a separate step. So what does that mean is, so for example, if you have multiple application dependencies, so if you want to copy a couple of files and then run an environment variable and then again copy some things across, or maybe do some other commands, you would probably want to do them in separate steps because one, it's easier to debug, and then two, you would understand how the flow is happening. Another thing is advanced topic here, which is called a multi-staged build. Just to give you an idea of what a multi-staged build is, you could have, let's say, for example, Google Chrome as a Docker image, and then your application, let's say a testing suite as your Docker application, and then you could combine these two in multiple Docker stages. So, and that was your image size would be very little. Again, multi-stage Docker builds are relatively new concepts. Again, these are advanced topics. We'll probably not talk about them a lot more. And then use templating to reduce dependencies across repos. What does this mean is try to template your Docker file so that you don't have multiple Docker files. You could have a single Docker file that would do multiple or package multiple applications. Right. Now, before we proceed on to the next session, I'll quickly share my terminal again. I'll quickly touch base on Docker Compose because we are, again, it's an advanced topic. We don't want to talk too much about it, but I'll just show you how Docker Compose file looks like. Now, if you can see here, this is an example of a Docker Compose file. Again, this is taken from the internet, from some website. Just to give you an idea of what it looks like, right? So some of the key components of a Compose file here, you are using version 3 of Docker Compose. Before version 3, you had version 2 and version 1. Version 2 is still in use. People still use version 2 of Docker, although it's slowly being deprecated, and you are advised to use version 3. Of course, it does have some nice advantages over version 2. And then you have a thing called services. So what this instructs Docker is to spin up all these images or applications under the services section. So for example, in this case, we are using Redis with a Redis image of Alpine, and we are exposing these ports. We're using another database with an image called image for Postgres. We are setting all these users and ports. And then we have our application, which does a number of things, and then we are exposing our application or a visualizer in this on port 80 and 80. What Docker Compose lets you do is to basically spin up all these containers in one go. You can configure it with additional ports or replicas or passwords and things like that. And once all of this is done, you could just have a local working copy of your application, and then you could start troubleshooting or deploying or doing anything of that sort, right? So it makes your life a lot easier. And once everything is done, you can easily tear down your application as well. So let's just quickly try it. I know it might not work, but we'll just give it a try. We'll just see what is running now. As you can see, we just have 2 images running. They've all stopped, which is fine because we pressed Control-C to exit out of the container. Now, let's say Docker Compose, and we'll just say up. So basically what this means is bring up everything that you have in that particular services section. One point to note here, I already have all the images that I need with me cached locally. So if I say Docker images command, I do have all these images cached locally. When you run it for the very first time, it might have to download all these images, so it'll take some time. But otherwise, if we say Docker compose and then say up, it should just start everything or all your containers in one shot. And you should, of course, this bit will not work because I've not tested this application, but ideally you should have your application working and whatnot, right? So we'll just wait for it to say done everywhere. And of course, it'll start printing some logs on the screen. It tells you what it's doing and sort of that. Let me press quickly Control-C here to make sure it stops. And as you can see, when we stop all the applications in one shot, or all the containers in one shot. That way you get an end-to-end environment where you can test everything, including the database, web server, application, and whatever. So if you say Docker ps-a, now you can see, yes, these 2 images were there before, but all these containers started up, and then I press Control-C, so they all went down, which basically is exit 137. So yeah, that probably gives you a better idea of what Docker Compose is. I'll not talk too much about Docker Compose. Let's get familiar with the idea of Docker, using Docker, and then come to Docker Compose if required. Right. So that sort of comes to almost the end of this session. There are some practice labs for you guys. If you want to practice using Docker, some tips: you can install Docker, you could create and run your own Docker images, you could explore around the container, maybe create a Docker file and then try running or create a Docker container out of it, then create new images, and then if possible, try running a sample website inside Docker and see how rapid application development works, right? And then let's quickly open up this floor for questions. We sort of have some time for question and answer. So if you have any questions, please ask. And then I'll try to answer it as much as possible. If not, yeah, I'll wait for questions to pop. Any questions, guys? If you don't have a question, please let me know that you don't have a question. That way, I don't wait for you guys. And yeah, I can answer any other questions that come up. Okay, I have a question here. Hi, Sunil, like Nginx container, what else containers can we use? Excellent question. So probably what I could do is probably have a browse or a look around our Docker Hub website, right? So let's go to Docker Hub here. And let's not go into our repository, but let's just search for content, right, to see what is there. So if we search for, say, Apache, so if you want to use any container for Apaches, you can see the amount of results that you get. So you have tons and tons of containers. You have containers for Zookeeper, Cassandra, Tomcat, HTTPD, and you could use any of these for your application development and your application lifecycle, right? So if you, let's not Apache, let's search for something else, say, one of the applications that we use, say Vagrant, right? Probably Vagrant is not a good idea. Let's say Packer. I don't know if you'll have one, but yeah, there you go. So you do have an option for Packer. So you have a container for Packer. You could use this container to spin up a Packer container, pass a parameter to it, and build your images. So let's see the instructions on here, right? So they're saying how to use it as well. So you say Docker run with your arguments and with your container or the image name, and then pass some commands to it. I hope you can see the screens. I'm just zooming it in. So there you go, some example commands as well. So it's pretty verbose or pretty well documented as to how you can use these containers here and what you can do with it. So if you, let's say another image, so Postgres. This is a database. It was updated 9 hours ago. So when you say Docker pull Postgres :latest, it will pull the latest image. But then you also have other options. So you can pull a Linux image, you can pull an 386 image, you can pull an ARM image, a 64-bit Postgres image. Again, everything will be latest. But if you want an older tag, they will let you know as well. So if you click on tags here, they'll tell you the available options. So you have Postgres :Alpine, you have the 9.6 version with Alpine and things like that. So you have for multiple architectures, multiple versions, multiple options. So that was, it's really, really good. All right, hopefully that answered your question. Is there any image limit for the Docker Compose? When you say image limit, I assume the amount of containers that you can spin up. Probably not. You can probably spin up 15 or 20 containers at the same time. The best or the maximum that I have encountered is, I think, 17, and it was fine. I would say there's no upper limit. Again, I'm not an expert on it. I'll have to check and get back to you, or we'll have to Google that. But yeah, it basically depends on after certain number of images come up, it depends on your system and your load and how much it can handle. You can't expect a machine with 2 gigabytes with a dual core processor to run 16 or 17 containers in one, but presumably on a server, yeah, it should be very easy. Cool. I have another question here. We have seen the pros and advantages of using Docker. What are the main drawbacks or cons, if there are any? Look, advantages, yeah, we already spoke about faster application lifecycle development and things like that. But in terms of cons, I would say learning curve. There is a little bit of learning curve involved, especially in using Docker Compose and things like that. But once you get the hang of it, you will probably see more and more cons of it. More and more pros of it. Look, Docker is one of the widely used container platforms in the market. It is used everywhere for application lifecycle development, and most people see advantages of using Docker rather than disadvantages. Hopefully that answered your question. Still waiting for questions if there are one. Okay. So if anything happens during provisioning the deployed container, will there be any downtime of the app? Look, while you're building a container, no, you're just building a container and all you're doing is tagging it and keeping it ready. So it's just a build. You could do several builds, and basically there's no downtime for your app because you're building it locally. But while running it, yes, depends on your use case. There could be a downtime, or you could avoid it using different ways. So for example, a little bit of an advanced topic, you could use a container orchestration platform like Kubernetes to maintain and manage your applications, where your applications are rotated on the fly, right? So although you have connections coming in, you could have sort of a blue-green deployment where certain number of users would be targeted to a new image, and slowly you will drain connections on your old image and send everyone to the new image, and then decommission your old image. So Kubernetes has this option to do it. You have Docker's own tool called Docker Swarm, which also has this ability to do it. So yeah, there are multiple ways on how you could accomplish this. If you're running this on AWS in their ECS containers or something of that sort, it takes care of it for you as well, where it'll do step-by-step provisioning. But yeah, you could avoid downtime easily with Docker containers. Excellent. Cool. I'm assuming that's the end of the questions. Let me quickly check. I haven't missed any questions. Cool. So, all right. Thanks, guys. I hope you've really enjoyed the session. If there's any feedback, please do let me know. I'll share this content and the Docker files and everything that I've done across. Look, the Docker containers that we created, they're already on Docker Hub. It is live. You could download it or pull it anytime using the Docker pull command. And you could pull down new images or that particular image and run it, and you can see it in action. Cool. Thanks, guys. Is there another question coming? Cool. That's it. All right. Thanks, guys. Thank you for your time. And see you in the next session then.